Okay. Well, hello again, ladies and gentlemen, and welcome to the last day of new material for proofs. How does that feel? You survived. Okay, this is going to be, if you were able, okay, yesterday proving triangles congruent, this is going to be even easier. Okay, we're proving triangles similar. Okay, remember, similar triangles only require two angles to be congruent to two other angles, and then they're similar. You don't even need to prove any sides. Okay, so let's go through a couple of these. You may recognize these first two diagrams from when I derived the lengths of segments rules. In other words, lengths of secants. The length of the entire secant times the exterior equals the length of the entire secant times the exterior. All of that had to do with similar triangles. Okay, and building the proportions and cross multiplying, if you remember how we derived those. And the same thing for number two. This is how I derived the products of the segments would be equal when two chords intersect. We proved those two triangles were similar to each other. We built a proportion of corresponding sides, cross multiplied, and that's how it ended up. That when you have intersecting chords, the products of the chords are equal. Okay, so anyway, that's these are the proofs that go along with the way I derived those rules. Anyway, so here we go. So R, QP, and RST are secants. R is congruent to R, of course, because it is by reflexive. Okay, angle 1 is half of QS, and angle 2 is also half of QS. Okay, described angles equals half their intercepted arcs. So angle 1 is congruent to angle 2. So halves of the same arc are congruent. All right, so those two triangles, RPS and RTQ, are congruent by angle. And here's number 2, okay, using a couple of the same ideas. Okay, AB, BE, ED, and AD are all chords. Okay, angle 1 and 2 are both halves of arc BD, and angles 3 and 4 are both halves of arc AE. Inscribed angles measure half their intercepted arc. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Halves of the same arc are equal. Okay, 4, I threw this in. I didn't really need it. As soon as I had two angles congruent to two angles, I had the two triangles similar. But this was your other option as far as angles. You've got the vertical angles, 5 and 6. Intersecting lines form congruent vertical angles. So the two triangles are similar to each other. Now I wrote angle, congruent to angle, because that's actually what I showed. I showed all three angles of one congruent to all three angles of the other. You only need two. Okay, so you did not need step 4 at all. And you could have just said angle. All right, so there it is. I just wanted to be consistent there. All right, so look at numbers 3, 4, and 5. Okay, remember though, with similar triangles, you have the possibility of two different or three different types of proof statements. Number 3, you're proving the two triangles are similar. Number 4, you are proving a cross product. Okay, and number 5, you're also proving the cross product. So remember what you have to do first with the cross products. You have to determine the proportions. Okay, then which triangles to prove them similar, and then have the proportions and then the cross product statements. Okay, so just remember that for those last two, a little final practice on similar triangles. But there it is. All right, so good luck, and I'll see you next time.